Last one we talked about was translations. There are four types of transformations. They are translations, dilations, reflections, and rotations. Rotation is going to be a video all on its own, but I'm going to try and hit translation, dilation on this one, reflection on another one, and then rotation on another one. The heavy hitting words are pre-image and image. Pre-image is what you told me was what comes first, the original picture or the original coordinates. And the image is the thing that is the copy, and it also has a little mark, and that's called a prime. So like A goes to A prime. This is the pre-image. This is the image. All right. So translation, let's just review that real quick. So if we had a point at 2, 2, let's call it X. So 2, 2, and then we wanted to translate that X plus 2, Y minus 2. Then we'd be taking our X value and going 2 to the right. So 1, 2. And then our Y value 2 down. 1, 2. And then we'd plot our X prime. So all we did was move it to the right and down. You should be able to look at the rule that's given and say, okay, I'm going right and down before you even do anything. You can also substitute these numbers in for X and numbers in for Y. So remember, a translation is code for slide. That all that means is it's moving the same distance, direction. It still has a congruent figure. It doesn't change anything. It's not changing the size or the way the shape looks. It's just moving it. Now let's take a look at a dilation. These are pretty simple. So going based off of knowing what simple substitution is, I went ahead and plotted A, B, C and made a triangle. I listed the coordinates right here. Okay. And I posted the rule right above it. So the whole purpose of the pre-image and the image and why that's so important is so you can understand if you're getting an enlargement, the figure's getting bigger, or a reduction, the figure is getting smaller. You have to be able to do that by identifying the original points. And you do that by using the prime notation. So let's go ahead and take a look at what it looks like to have these original coordinates, 0 and 2, and substitute them into the rule that's listed above right here, and generate our new coordinates and plot those. So you can see that it says 2 times X, comma, 2 times Y. All right, that means we're going to make something twice the size. So we're going to take all the coordinates and double them. So watch this. 2 times 0 is 0, and 2 times 2 is 4. All right, so we're going to go over 0 and up 4. Okay, you can see here that A is twice as far away from the origin as it was before. Negative 2 times 2 is going to be negative 4. And then 2 times 0 is 0. So we're going to go left 4, up and down 0. That's going to be B prime. You see that it's twice as far as B was from the origin. And then 2, 0. 2 times 2 is 4. And 2 times 0 is 0. You're going to take a guess. Yeah, you guess right. It's going to be twice as far. Okay, so that's going to be C prime. And then when we make a triangle, you'll see that it's way bigger. Now, the determination of which one is the original is by looking at the prime notation. That means that you're looking at the copy. Okay, this is what happened when you used this rule. These are your original ones, your A, B, and C. That is the most crucial part of this to be able to figure out, okay, was it an enlargement or was it a reduction? And then we can start making our way through determining, are we going to be working forward or backwards? And during tutorials, you and I will be working on that, getting a little more complicated end of it. But really, you can type all this stuff in your calculator: 2 times 0, 2 times 2, and you come up with coordinates, rewrite them, plot them, put the prime notation. Labeling your points is going to be the biggest issue with understanding all the different types of transformations. So just keep in mind, the regular letters are your original. The ones with the prime notation are your copies. That's what happens after you do a transformation. So you can see this is the only one that will change the size of the shape. This is the only type of transformation that will not create a congruent figure. It's going to be the same shape, but not the same size. So it's going to create a similar figure, but not a congruent one. That's important that you know that. Similar, not congruent. This is the only one that does that.